today is our week 14, yeah. So that means we only have another 1 week, which is next week, for our last lecture for this subject. Okay, so 2 more last chapters, which is air pollution, and another one is noise pollution, which will be given by next week. Okay, so air pollution, 100% is theory. So that's why I'm invited our ex-student, alumni, your senior, to give an overview or insight about the workforce or experience on air emission monitoring. Okay, so let me start. So basically, for this chapter contains about these topics, which is on the classifications of air pollutants. Hopefully today the network is okay. I'm standby using my phone. Kalau apa-apa beritahu saya, boleh tahu tiba-tiba saya cakap seorang. And then air pollution standards. So anything about regarding to the certain target of the pollution control, you need to have certain standard to comply with, especially when it goes or deal with the human health and also the environment. So any country in the world, they have some standard, and normally they have a one global standard that they follow, but they adjusting accordingly what they are to accommodate their country. Yeah, and then the methods, the ambient air monitoring, quality monitoring. Ambient means the outside temperature for the normal temperature, not indoor. And then air pollution mitigation and control at the construction site, because your work will be mostly at the construction site for civil, talking about the civil engineering discipline. Okay, let me ask you before I proceed. Okay, comparison between the water and air pollutions. So which do you think is very difficult for you to measure and why? Anyone? Ada siapa nak cuba? Okay. Okay, in all of this, what we have taught before, can you learn about water, wastewater, right, to determine. It's easy because for water, you can clearly see from the color, betul tak? Okay, if our water is clear like this, tak tahu nampak tidak, then if you can say that some contaminants due to the turbidity, we can see clearly due to color. But for air pollution, okay, even though that certain gases are colorless, so it's very difficult to identify the emission because it's colorless. Some of the gases, nanti kita akan go through. Faham tak? Maksudnya, we can have the option, okay, to have good drinking water, for example, but air, can you have an option? Saya masih ada lagi tak ni? Tak nampak lah. Ada yang tulis kat sini dekat chatting box ke? Tak ada kan? So saya tanya dekat siapa? Abu Hafizuddin, regarding the air pollution, kan? What is your opinion?
Yes.
So that means in water we can have option, right? Due to the color. For gas, for air pollution, can we also do that? Can we say, oh, I don't want to get the oxygen today? Can we do
No,
that?
no.
Why? Kenapa?
Sebab udara tak boleh dilihat.
Yes, tak boleh lihat So this is a very complex situation when we actually somehow we have bad air pollution but we did not notice due to the some of the gases are colorless. Okay, itulah cabarannya. Okay, so air pollution, as we know that any substance can give harmful to the environment. Okay, like this, certain gases like nitrous oxide, they can give color like a brownish color, but the others is colorless. Okay, then next is about the classification. Primary pollutants made from the direct source. That means from the what we call that, the first source that emit from the for example certain emission. Secondary means they are actually can convert into something, okay, from the primary pollutants. Okay, for example, ozone actually comes from the elements, okay, from the nitrous dengan sulfur oxide, okay, and then it can convert to ozone. And also secondary pollutant is like a organic aerosol to form haze. So both of these are very important classification to identify for the air pollutants. So yang bahaya sekali, the most danger is secondary pollutant when they convert into something gases. Yang ini pun for the primary, if at a certain concentration which is very high, is giving effect to the environment of course dan juga to the human health, especially for those who are having respiratory illnesses like asthma dan sebagainya. Okay, then usually to detect the air pollutants is from the particulates. Kalau dalam air, in the water, we measure by suspended solid, right, in the water. So in air also, we can measure by using the particulate pollutant, but this one we need to capture by using the device. Okay, the size ranges from this one because we need to calculate how much is the particulates from the lead, for example, from the fly ash, and then we think that it can carry certain particles which is sometimes is harmful to the human and environmental health. All right, and then so the gases can occur in two types of sources. One is from the natural sources like volcanoes and forest fires. Another one is from the anthropogenic. Anthropogenic is actually from the human made. Okay, that alter the emission. Okay, from the industry, from the what we call that combustion of vehicles and so on. Because of the population growth, so we need more transportation, we need more industries, okay, to for our necessities. So this can contribute to much more greenhouse gases to the environment, to the atmosphere especially. Okay. Okay, before I proceed, I would like to ask everyone, okay, which country has the highest air pollution in the world? Country yang mana?
Bangladesh.
Oh yes, correct. Sebab you Google kan? Okay, second one apa? Second one. Tapi tadi ada Google juga. So the first one, Bangladesh. Lagi, Bangladesh is also one of the industrial country, especially textile. Nombor dua siapa? Negara mana?
Pakistan.
Pakistan Okay. Malaysia tak ada? How about Malaysia?
Malaysia 50.
50. So top 50 lah
Ya, top
Ah.
50.
Top 50 lah masuk, walaupun 50 lah yang last kali. Okay, not bad. Okay. Kita masih lagi terkawal lah yang lain ni saya tengok mostly developing countries. Okay. So mostly they are actually producing lots of industry, is it? Okay. Itu 50. Okay, yang developed country pun kita Korea Okay. So actually they have the instrument to measure the polluted countries in the world by using the certain IoT dan juga big data ni. So I don't know how they measure. Right, then here, okay, back to science So for in our atmosphere, we have mostly contains of nitrogen, okay, and then oxygen for us to survive and breathe, argon and also the others constituents. Okay, tak ada apa lah. So if you are ni dah punya labels of the atmosphere, they have 5 main layers. Kita biasa sampai troposphere sajalah. When you are what we call that, taking a flight to your destination kan, sinilah sampai sini. So atas ni no, because ni dah ada ke level kayangan sampai atas. Alright, ni nak tunjukkan just ada 5 main layers of the Earth's atmosphere. Then okay, these are the major sources of pollutants mostly for industry. They contribute to the high levels of SO2. Nak tahu SO2 ni is very easy. You can find the white smoke from their stack. Itu mostly SO2 from their sometimes I don't know, some boiler, and then also they have used some acid, okay, dan sebagainya. Tapi ni they have mungkin acid they use for the preservation, okay, tapi biasanya yang keluar tu at a certain level must comply with the Department of Environment. They must actually have the regular monitoring lah, report to the JS. Sepatutnya lah. Okay, so these are the health effect and also the environmental effect. This SO2 ni if high, they also can contribute to the acid rain when they mix with the with the rain lah, with the rain, and they keluar nanti sebagai acid rain and then can damage to the aquatic life, okay, pH rendah, so lower pH in our water and damage also to the buildings. NOx, nitrous oxide from the vehicles and industry. PM ni bukan Perdana Menteri, not Prime Minister, but this is a particulate matter. Particulate matter debu lah. Debu or what we call it, particulate. Yalah particulate lah. Particle. Kecil sangat. But contohnya in my lab, makma saya, so we have the device to capture this particulate matter and then we need to calculate. Ataupun dia boleh auto jugalah. We can calculate how much of the particulate matter in our surrounding. Ada siapa in the campus, student in here? In our faculty pun ada yang pasang they are installing the device to measure the levels of air quality in UTHM. Okay, CO is a carbon monoxide from the vehicles mainly. So this is the health effects. Okay, CO ni carbon monoxide sometimes due to the alterations of the absorber tu, saya pun kurang faham sikit in the vehicles also can contribute to the carbon monoxide incidents yang tiba-tiba meninggal dalam kereta, itu pun boleh satu puncanya. CO ni they can replace the hemoglobin in the blood, okay. Maknanya dia akan replace sepatutnya kena ada oxygen but replace with the carbon monoxide. That's why the human that affected with CO gases, dia akan pengsan. Pengsan ada certain time, kalau tak ada yang perasan dan sebagainya, so boleh meninggal dunia ya. Okay, lead and ozone and also the VOC is a volatile organic compounds ya. Okay, from the vehicles and also certain industry that processing certain volatile organic compounds. Okay, so you can see in here the major air pollutants. Boleh baca lah. At least you must know a few ya. And then how to determine our indexing in Malaysia. In Malaysia in terms of air pollutant index. Okay, so we will know about this the quality status based on this API. So for the macam WQI lah. It's like a WQI that you learn in chapter berapa? 3, is it? 3 or 4? 3 ke 4 Bala. So ada kita we mentions about the WQI in which chapter? Bala tak ada?
Yes, doktor.
WQI for water quality index. Which chapter that we learn that? Chapter apa tu? Ada ke? WQI ada kan? Dah lupa dah. So you all punya exam final bila? hari bulan. Bukan 18 Is it 18?
Yes, 18.
18 ya. Kita jangan tengok yang lama. We need to see the update one lah. 18 18. So put that in your diary in your calendar. Okay, so WQI kita baca kat mana tu? In chapter, which chapter?
Chapter 4.
Chapter 4 on water supply kan? Ada 6 parameter for WQI Kalau on the API 1, 2, 3, 4, 5 5. Ozone, carbon monoxide, nitrogen dioxide, sulfur dioxide and particulate matter 10 micron. 10 micron ni size lah. Maknanya nanti in our device kan, we need to put the set of 10 micron. Maknanya less than 10 micron the device of the PM10 ni they can capture. Maknanya ginilah. Particulate matter ni below than 10 micron they can penetrate into our respiratory system. Maknanya boleh masuk dalam kita punya badan. Okay, in Singapore they have lower than that 2.5. 2.5 ni dia boleh masuk lagi dalam in our respiratory system. Tapi kita pun dah dengannya akan juga wujudkan for 2.5 punya measurement Kan kita masuk lagi 10 micron. Okay, how to measure? Dia depends on the time. Kita kena letaklah device kita ada sensor dia, alright? Kalau SO2 24 hours, PM10 24 hours 1 hari, ozone kena 1 jam, CO 8 hours, nitrogen dioxide 1 jam. Okay. Device dia depends on the what parameter you want to collect and then dia punya sensor tu pun different got different sensor as well. So nanti kita akan calculate and kita akan calculate total of the API. Okay, then after we calculate, we can classify lah which one good ke moderate. Okay, boleh baca sendiri. Okay, and this is the averaging time. Tadi saya dah explain. Kalau kita nak tengok dekat mana, dekat sekejap mana dekat tengok dekat DOE DOE Malaysia. Kat sini ada dia punya real time. Saya cuba buka. Kalau ada lagi lah. Dulu saya pernah buka. Okay. Saya share dekat sini. Nampak tak? Tak keluar. Yang ni. Pergi ke DOE ataupun JSR Malaysia. Dia ada sistem Air Polluted Index Malaysia. So this is the real time. Kita duduk kat mana? Contoh kat bertempat lah sini kan. So bertempat kat mana? Ni kat mana ni? Ni Melaka, Melaka moderate. Kalau 46 ni dekat bertempat. So in bertempat, okay, good. Good dia punya air quality So Kai, ni dekat mana sekarang? Sarawak Kuching ke kat mana?
Ya, dekat Sarawak, Kuching.
Kuching ni ke? Mustahil.
Ya.
Kuching sini. So Semarahan. So sini basically good lah kat Kuching pun good. Cuma yang ini hijau kat moderate ni dekat Bintulu. Bintulu ada apa? Bintulu ada industri Okay. So yang ni moderate ni tengoklah kat mana ni, dekat KL, Batu Muda, siapa duduk KL. You all semua dekat sini ke dekat hometown Kat rumah sewa ke kat mana?
Dekat sini.
Oh kat bertempat So bertempat okay, tak tercemar So kat sini, kat Pulau Pinang moderate, kat Minden. Lagi dekat Kota Baru, okay. Ni semua bandar besar lah ni. Ya. Terengganu, Kuala Terengganu ni semua bandar-bandar besar, big city. Kalau kat Johor pun sama. Semua yang big city ni kebanyakannya moderate lah. Yang lain is good. Good, moderate. So okay lah So if you want to see real time of the air pollutant index management system by Department of Environment, you can go to their website lah and see. Gitu. Okay. Saya continue balik. Okay Ada soalan tak setakat ni? Very straightforward for air pollution. Inilah contoh tadi. So tadi yang saya tunjukkan is the real time. So you can say lah which location are you. If you are very concerned about air pollution, you can check selalu. Tapi nak install as a app, I'm not sure. Ada ke tak ada. Ini basically for those who are very sensitive to the air pollution from the haze and everything because ada asthma dan sebagainya lah. Alright. Very general. Okay, industries that sources of the air pollution in Malaysia basically from the iron and steel mills. Kan ada banyak akan ada blast furnace. So dia akan banyak ada what we call that contribute to the particulates. And then another one is about the Tanjung Piai atau apa namanya is a charcoal coal operation for energy pun sama. Okay, petroleum refineries, Portland cement industry, asphalt, and then sulfuric acid, Okay, it can contribute to the high sulfur dioxide, glass and glass fiber and so on. Okay, how to control our air pollution is some industry they need to put the some equipment or tools to minimize the air pollution. For example, here by using this settling chamber. Okay, so for example here ada dirty gas in, dia pasang lah. Nanti dia ada macam ni, apa nama ni, the combustion ni. So they can collect the particle in here by using the dust hoppers, so the cleaner gas will be out. Other than that is a cyclone. Okay, cyclone macam ni, macam dekat when we watch a US movie ada cyclone tu kan. So dekat sini adalah cyclone dia, then the dirt will be flushed out in here as a dirt. Macam tu je lah, boleh baca. So at least kena tahu jugalah how to do this particulate control. Another one is by using the big house like this. Okay, the macam ni lah punya sistem kereta kan, ada ataupun vacuum, dirty air flow into and through a number of cloth filter bags that are placed in parallel. Jadi ada apa ni, cloth bag, filter bag. So the filter remove the particulate from the gas stream and clean the gas pass through the cloth. Dia macam biasalah like a vacuum cleaner or certain what we call that filter cloth. This is the bag house. And then how to control the gas is by using the adsorption. So we can remove one or the more selected components from the gas mixture by adsorption, penyerapan. So in the process which is gases pollutant dissolved in a liquid solvent like NaOH or acid sulfuric. Okay, so if the liquid absorb the gas in much way, the sugar is absorbed in the water when stir. So konsep dia sama macam ni, absorbent. So this is the photo of the absorption process. Okay, so the dirty gas inlet and then go into this material, scrubbing vanes, spray, and then the scrubbing liquid inlet for here to do the absorption. So the clean gas outlet will flush out. Okay, ini boleh baca sendiri. So this is the process or steam containing the carbon dioxide and how it can decrease, what we call that, remove the carbon dioxide rich gases in here by using the absorption process. Or okay, this is like that we taught in landfill, we can do the flaring ataupun we burn the gases. We burn the gas, we combustible waste react with the burner. So flaring, this is flaring type of method. We actually use the thermal incinerator. Okay, we can combustible the waste gases. Maknanya certain gas is very toxic. So by using the flare, it can burn out the gases. And okay, examples of the gas incinerator. And then next is about the ambient air quality monitoring at the construction site. Right? Okay, this is compulsory because as we know that during the construction process, there are lots of the activities that can give more, what we call that, dirt or pollutants in the atmosphere. Banyaklah abu-abu particulate matter, right? So most monitoring plants are designed with a human health objective. So we need to have the monitoring station. Okay, especially when the construction site is near to the very sensitive area in the residential area, school, hospital, or area with the human activity. So we need to have the main consultant. If you are main consultant, then you need to have the air monitoring station. So you need to see how big, if your project, it must be a very big project, that lots of these emission or particles can emitted into our atmosphere. Okay, So you need to apply this action and limit for the monitoring of air quality stated by Departments of Environment and Arahan Kerja JKR. Okay, this is their procedure. So the audit must be compliant with the contractor in regards to the dust control. Okay, contract conditions and must are relevant to the dust impact criteria. So in this ANL must see the effectiveness of the mitigation measures. That means how you control the air emission ataupun you punya dirt or dust control during the construction. And then if anything what we call that happens or the dust is very what we call that much than you think, than you expected, then you need to recommend the further mitigation measures if this is necessary. Okay, so all the construction activity must comply with the environmental control plan as described by the bill of quantity BQ at non-physical works for air quality monitoring. So at the BQ, air pollutant is one of the criteria to be monitored. Okay, as a standard by JKR and also the DOE, Departments of Environment. Okay. So actually there are no ambient air quality standard in Malaysia, but we have the recommended Malaysian air quality guideline. Ambient means the outside air. Okay. Okay, this is examples of the procedure from the JKR Malaysia about the construction at the Bandar Besar Baru, Ampangan and tempat letak kenderaan bertingkat in Seremban. So we need to state the non-physical works. One of it is the air quality sampling. So you need to conduct monthly air quality monitoring for particulate matters, PM10, particulate matters 2.5, the paling kecil 2.5, NO2, SO2, CO and ozone for 24 hours, right? Okay, this is examples of the particulate sampler for monitoring the total suspended particles untuk dust dust punya dust control So we need to give a report monthly monitoring to the JKR and DOE Okay, so they must have the standard. So TSP level of 260 microgram per meter cube for 24 hours average. So it should be used as a benchmark. Ini kita punya benchmark lah. Kalau exceed the value, then that means there are lots of dust in your construction area, which is can give a detrimental effect to the surrounding human health and also the environment. Okay, ini guideline, right? And we also have this National Ambient Air Quality Standard. Okay, from the EPA, Environmental Protection Agency. For the 6 principal pollutants, ini yang paling kata significant or main pollutants that we need to control. And mostly this is the National Ambient Air Quality Standard. And compare with the US and WHO, lebih kurang je lah sebenarnya. Kalau kita set the standard ni, mainly from the World Health Organization, kita refer lah for the developed countries like USA and Malaysia, plus minus lebih kurang lah, depends on what we want to target in our country. Okay, then this is the methods for the air pollution control. We have, for example, cyclones, electrostatic precipitators, fabric filter, wet scrubber, saline chamber. This is to remove or to minimize the particulate, okay, or dust. Particulate sama dengan dust, same. Okay, particulates. And for gases, we use absorption, or direct combustion. Okay, kalau absorption ni on the surface, tapi absorption dia boleh masuk dalam kita punya sistem. Di dalam ni, maknanya dia absorb ke dalam ya. And okay, how to control the air pollution at site, or especially for the dust, we need to have always the watering on the work site, skip hoist for metal transport should be totally enclosed by previous sheeting. Okay, ada vehicle washing facility so that the dust not be everywhere. The vehicle washing takes place at the section on the road between the washing facilities and the exit point. And every manhole road should be scaled with concrete and kept clear of dusty material or spray or with water to avoid any dust from flying in our area. Okay, the main concern is that the dust with a certain size, okay, it can enter into our respiratory system. Itu yang kita nak lah. Then itu yang menyebabkan can cause a lot of the issues for the human health. Okay, ni boleh baca lah . Okay, examples ada cement covering like this, cement covering supaya dust tak fly over, or we need to do lots of this watering or washing . Okay, the exit was through ni kena ada ni lah, bersihkan, cleaning the pipe of the truck that carry the, what we call that, sometimes sand, soil dan sebagainya for your construction materials . Okay, then that's all for the air pollution. Any question? Tutorial ni nak buat ke? I will put in the, what you call that, in the author, so you can do the tutorial for our last tutorial. Okay, I think you can submit to me by next week. Semuanya jawapan ada dalam nota ni sebenarnya. This is good for your revision. Okay, is there any question regarding to the air pollution? No? Okay. So at 3:30 we have the invited speaker to talk on the air emission, okay, performance from the industry overview. So I believe that that one is very good exposure to all students about the emission or air quality. So if there is no question, then we can proceed with the group presentation. We have two more. We have two more groups, kan? Group 10 and group 11. Group 10, are you ready? If you're ready, you can share your screen. We
Okay, sure. Okay, we are ready. Yes.
Okay, nanti dulu. Sekejap, saya open your file first to check. Jadi dah buka saya. Sudah.
Yes.
Okay. Macam ni saya buka. Nak baca punya ni. Fine. So you can share first. Okay, you can proceed.
Saya mula, Doktor?
Boleh. Silakan.
Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon to Dr. Adin and all my friends. My name is Muhammad Haris bin Abdullah. My metric number is DF20083. So since we have a very short time period, now I'm going to start our group project presentations entitled Industry with Air Pollution Control. So what is meant by air pollution control? It is the process on how the industry manage the production to become environmental friendly so that pollution can be avoided. As we know, air pollution is a worldwide issue that must be taken seriously as it leads to the health of people and also our environmental system. If we are having a bad air through our daily life, we are going to have serious problems regarding our own health later or sooner. For background study, up until now, there has been a significant increase in public and government awareness regarding the impact of contaminants on human health and the global ecosystem. The results of our analysis regarding these air pollution issues will be discussed to improve the quality of the atmosphere for the Earth's healthiness. Hence, to analyze these issues, we have come up with one problem statement, which is air pollution has causes bad effects in terms of health and safety for the public. So, how the industry controls their air pollution during the production. In order to get further understanding regarding this problem, we have come up with two objectives, which are to know the level of the awareness and the current implementation of the system and technology in Malaysia and worldwide. Because most of us would be an engineer in the future, I believe. Therefore, within this knowledge, we have the right direction in order to make successful changes and improve our environmental system. The second one is to identify the current practice of the treatment in the system at the industrial process. For example, how an industry should have the method or technique to avoid bad air emission to the environment. And for the last part of our introduction, we have two significance of study, which are identify the main causes regarding air pollution issues in Malaysia, because it is very essential to know the roots of an issues in order to solve the problem. And the second one is determine the sources of air pollution and how we can control the air pollution, especially for our industrial activities, because it is very closely related to the emission of air pollution to our environment. That's all for introduction. Up next is literature review by Alia Raza.
Okay.
Thank you, Harith. Assalamualaikum to Doctor and my fellow classmate. I will explain briefly about the literature review. As what Harith had mentioned earlier, the air pollution is defined as pollution of the indoor or outdoor environment due to chemical, physical, or biological factors that alter the unique properties of the atmosphere. So according to World Health Organization, almost the entire world population, or 99%, surpass WHO guidelines and inhales air containing prominent levels of particulate matter, with low and middle income countries and struggling the most. So in accordance with the project titles, this report specifically focuses on how the factory control air pollution. So the regulation are critical for the plant or facility to fulfill compliance and reduce air pollution demands. So these are the three common equipment on how factory control air pollution. So the first one is waste heat recovery equipment, new thermal oxidizer technology, and the last one is wet scrubber. So I will pass you Dave. Thank you.
Thank you, Heng and my name is Pang Kambao. A very good day, Doctor, and all my fellow friends here. Today, I would like to present to you about the result and analysis of our projects through which is done through Google Forms and regarding to the level of awareness of the society. So this Google form is specially designed by 3 aspects. The first one is demographic characteristics, and the second one is the level of awareness of respondents about air pollution and their knowledge about air pollutions. So next, the first part is about the respondents' demographic characteristics. So as shown here, there's actually no mass bias in gender and the residence of the respondents. However, there's a huge bias exists in the age, educational level, and residence periods of the respondents. And the attachment that is that the study area is nearby the universities. So therefore, the major group of the respondents is between 20 to 25 years old with tertiary educational levels. And most of them are local people who live above 10 years in study area. So the second part of my presentation is the level of awareness of respondents about air pollutions. So in these sections, there are totally 10 questions being asked for these sections. So overall, positive findings have been observed in these sections because most all the respondents presents their positive attitudes or response towards the questionnaires. However, the respondents have to pay more attention to annual report on air pollution because more than half of the respondents claim that they do not pay attention to the annual report on air pollutions. So the third part of my presentation is regarding to respondents' knowledge about air pollutions. In these sections, there are a total of 4 questions being asked. Then although with the high responsibilities of the respondents shown before, however, there are a few of the respondents still have chosen the wrong answers that have been purposely inserted into the options of the questionnaires. And this proves that some of the respondents do not require with the proper or correct knowledge regarding to the air pollutions. And I think that's all from me. Thank you. I will pass to the next member, Haziq.
Okay, thank you, Pan. My name is Muhammad Azifami. So I will continue our presenting with discussion. First point, I would like to touch about the current issue related to air pollution. Natural resources such as oil, coal, and chemical are used to various factories. These elements are capable of emitting high poisonous pollution into the environment. Factories emit harmful gases into the atmosphere that harm the environment by pollution the air. The cause of this problem is lack of awareness on how to manage the industry with air pollution in correct way about how to control it. Okay, next. Regarding to interview, we get feedback from Ms. Jean about commonly technology that used in Malaysia to control air pollution. So our group chose a vertical pack tower scrubber system. They are used gas scrubber that instead low energy. They are used for gas absorption, cooling, and recovery. Because of their high scrubbing efficiency and low power consumption, they are used in many industries for a broad range of application. Next, from Ms. Jane's opinion as an experienced exercise about possibility or intention about bringing in the technology in regarding regulation air pollution from other countries. Our group chose high efficiency particulate air filter HEPA system. It is made of a complex web of fiber composed of dense glass and plated, which increase the total surface area and create lower resistance to airflow. Due to the lower resistance, this filter high efficiency to remove particulate with the size of less than 0.6 microns. Next. For design operation of pack tower scrub, scrubbing liquid into the tower through a nozzle and is sprayed uniformly. Is enter the tower through the inlet near the bottom and pass through the support plate. Next, constant current to the flow of the scrubbing liquid, contaminant air removed. The packer bed is designed to provide maximum gas to liquid contact at low pressure drop. Lastly, the clean glass passed through a mist eliminator section near the top of the tower. Okay, so that's for our presentation. Its conclusion: air pollution generated by a complex relationship between the distribution and emission of dangerous chemicals from factories. This problem stems from a lack of understanding of how to manage the industry air pollution in a proper manner and how to reduce it. The most relevant and common method that used to control factories air pollution in Malaysia is by using vertical pad tower scrubber system. That's all from our group. Thank you.
Okay, thank you so much, Group 10, for your presentation. So very comprehensive data analysis. Yeah, and then you also did the interview, right, with the company? And then what's the analysis from the interview?
Actually, just now have been going through by the slide.
Okay.
Yeah. Let me show you.
Right.
Okay. Actually, this part is the findings from the interviews, because from the Master Jaya company, Ms. Chen has recommended the technology that are commonly used by her company, and actually there are not a specific answer because she claimed that for the specific pollutants we have to use the relevant technologies with different technologies applied.
Okay. So this technology is suitable for which industry? Did you know?
Actually, these are all for the air pollutions, regarding to air pollutions industries.
Okay. So they must have what correct comply with the standard for DOE, for the air quality
Yes.
emission. All right. And
If
then
yes, if we would like to know the regarding pollutants for the specific technologies, we can refer to Master Jaya's website, official website.
okay. Okay, another one is about your questionnaire analysis. Hang on. Can you show me your slide on the analysis for the survey?
Sure.
So from these results, can you summarize what is the level of awareness in Malaysia from your respondent? Is it high, moderate, or poor?
Actually, from the result of analysis from my part of discussions, we can conclude that the level of awareness of the respondents is actually high, because actually for the every questions answered in the questionnaire, you can see that overall positive findings, that most of the respondents answering yes compared to no options. Only these questions, they do not pay attention on the air pollutions. So the respondents who answers no in these questions is slightly more than those who have chosen yes.
Yeah, because one thing is because of your question, yes, no, yes, no. If you give
Yes.
what we call that certain option or to know their levels of awareness, that we could
Yes.
that we will know. Actually, the understanding is verified or not? Okay, oh, that's okay. Then okay, in Malaysia, because in THM, as we know, we are residing very near to the industry. So our main priority is our air emission, especially because we are located just beside the industry. So as a student, what is your aspiration? Okay, this is like a open-ended question to cater this air pollution in our campus. Anyone? Yeah, yeah, that's okay. Because now UTHM also this Evergreen actually have we have deal with on how to minimize the air pollution, because we cannot say you need to close the industry, because this is like a source income to many of the people in Pak Raja. So by improving their treatment system, their filter for air emission, that one can be controlled. Okay. So my last question, please tell me what are these 5 main parameters for API? Baru je kita baca tadi. Haris, Alia, Aziz, korang jawab. Carbon monoxide. Lagi? Lain? Okay, okay. Betul right. Okay, I think that's all for group number 10 for your presentation and also your Q&A. Ada apa-apa lagi? You want to speak up or anything? No.
No.
Overall good, yeah? Alright, that's it. Thank you, group number 10.
Thank you, Doctor.
Alright. Okay, group number 11, are you ready?
Doktor, boleh nampak skrin tak?
Belum lagi. Dah ada. Sekejap, sekejap. Ini pun pasal apa? Noise, Okay. Tunggu sekejap, saya pergi toilet sekejap. Okay dah, boleh proceed.
Okay. Good morning to our lecturer, Dr. Radin. Today we will present about the topic is noise quality monitoring at constructions activity and its control measure. My name is Sutipo, and I will present the introductions. Next. And in the introductions, we have already correct analysis the data by the online survey between the age from 18 to 31 in Google Form. Besides, we also progress the online meeting and get information about the bad effect of noise pollution on the residents and the suggestions from Mr. Bahari Muskatin, Site Safety Constructions. And next. In the problem statement, the noise pollution can affect the human health, such as hearing loss, high blood pressure, headache, and stress. The noise pollution mostly come from activity constructions, such as rebounding of the drop hammer and the sounds of the engine of the mechanical. That's all for me. I will pass the mic to my group member to continue the presentation. Okay, so Assalamualaikum to our lecturer and good morning. So today I will explain about the data analysis of our project. Okay, so for our project, we have made a survey in Google Form that we have collected 55 response from the public. So as you can see from the first right here, is the result of the age of respondent. Okay, as we can see right here, we have made from below 18 years old, 19 to 25 years old, 26 to 30 years old, and also above 31. So from the pie chart, we can see that the majority of the respondents are from age 19 to 25%, while small majority is from the adult, which is only 7.3%. And then we ask the respondent about their basic opinion about the noise pollution. So first of all, we ask them if construction is developing in your surrounding, do you feel annoying and disturbing? So we have provided two answers, which is yes and no. And we can see that majority of the respondent have answered yes, which is 19.9%, and a small amount of percentage of respondent answered no, which is 9.1%. From this, we can see that majority of the respondents feel annoying and disturbing while listening to the noise construction. Okay, next is the percentage of difference annoyance level from respondents. So the question asks if yes, please select the rate of annoyance level. We give them 4 options, which is very annoying, slightly annoying, annoying, and not annoying. So from the pie chart, we can see that majority of the respondent agree by saying it is annoying, which is because only a small amount of percentage answered not annoying, which is 10.9% of the respondents. Okay, next, in your general, what is the rate of sensitivity to the noise? So we also give them 4 options, which is extremely sensitive, very sensitive, moderately sensitive, and also not sensitive. We can see from the pie chart here, very sensitive brings percentage of 38.2%, moderately sensitive gives 29.1%, extremely sensitive gives the percentage of 23.6%, where only a small amount of respondent answered not sensitive, which is only 9.1%. And then we ask them, do you think you can focus on your work while being surrounded by the noise of construction? Okay, so we gave them two options, which is yes or no. So from the pie chart, we can see that majority of the respondent answered yes, answered no, I'm sorry, which is 74.5%, and only a small amount of respondent answered yes, which is 25.5%, meaning that they cannot focus while surrounded with the noise of construction at their area. So next, the result of respondent ability to rest. We ask them, do you think you can take a good rest with this kind of noise? We can see that majority of the respondent also answered no, which brings percentage of 80%, and only a small amount answered yes, which is 20%. And then we ask them, in general, what are the effects of sound pollution on your health? We gave them a lot of options, as we can see right here, which is headache, effect on hearing, mental health disorder, other health issues, or no effect at all. So by this pie chart, we can see that only a small amount of responded answered no effect at all, while other responded believe that it has effect on sound pollution. For example, hearing brings 40%, headache brings 20%, mental health disorder brings 20%, while other health issue brings 9.1%. Okay, for the next question, we ask the respondent, in general, what are the effects of sound pollution on your life? We gave them a lot of options, same as previous, such as reduce working efficiency, interfere with communication, sleep disturbance, stress, or no effect at all. So from the pie chart, we can see that there is only a small amount of respondents that answered no effect, which means that they believe this sound pollution has effects on our life, such as reduce working, interfere with communication, sleep disturbance, and also stress in our life by hearing the noise pollution. Okay, then I will pass to my group member. Thank you.
Okay, and I will continue the present about the output from the interview session. The first question we asked to the industrial personnel is, what is the person or party that is in charge of noise monitoring and control at construction site? The management company plays a vital part in monitoring the noise, and this is because they are under the responsibility of the employer. And the management will hire the third party to do the monitoring of noise at the site. This, next is the noise level according to the specification of the agency or ministry. So the minimum limits of noise required by our ears is 85 decibels. So if the noise level at the construction site has exceeded to the noise level, it is compulsory to propose a control measure to avoid the interference to the public. Next is the guideline or rules and limitation that have been regulated for the noise at construction site. So the guidelines used for noise risk assessment, NRA, is based on the occupational safety and health, which is the NRA handled under the Industrial Code of Practice. NRL also is required to competency to be hired for the construction to process the noise monitoring that needs to be submitted to the DOSH. Next. Next slide. So the next question we ask is which part of the construction stage produce the most noise? And the specification works produce the lot noise is piling and hacking work that require the use of air compressor and a huge machine. So to measure the control, monitoring is usually done on the site, while for the environmental field, focus more on the outside construction site that is near to the residency area. The solution and action to be reduced is at the construction is the body system, which the worker need to wear the PPE, personal protective equipment, which is earplug or earmuff. And the last question we ask is the type of device for the noise quality monitoring is in general sound barrier used in the construction, but for the worker is using by the body system and PPE. I will pass the next presentation to our group members.
Hi, Assalamualaikum. My name is Muhammad Shukri bin Jalal and I'll be presenting about enhancement to reduce noise pollution at construction site. And firstly, we need to know there are two categories of noise control. Firstly, passive noise control and second, active noise control. Passive noise control aims to reduce noise transmission, while active noise control aims to reduce noise emission at its source, for example, at the construction site. And enhancement to reduce noise pollution at construction site beside a busy street, it is best to install a temporary barrier that can be easily moved or pulled out of the way when it is not in use. And then there are three types of noise blocking materials, which are reflective, absorptive, earth landscape, or hybrid. And then as a most successful noise barrier, sound absorptive materials are often used. And one example of noise absorbing barrier is foam metal noise barrier. Foam metal noise barrier is best to use beside a busy street because it is simple to be installed, good in sound absorption, high intensity, strong, and also long lasting. And as we can see here, this is the example of foam metal noise barrier. Next slide. Okay, enhancement to reduce noise pollution at construction site. We need to know that to choose a noise barrier, it might comply its aim, which is to lower noise and also least in cost. And there are a few requirements of noise barrier, which are barrier must cover the length of noise source, and then the barrier must be thick enough to absorb or to block the noise. And then it must enough height to cover the noise. It must fit available space and also be enough to close the source of noise. So at the construction site, acoustic barrier can be installed. And then this type of barrier usually made up of smaller section, which make it easier to move and to relocate and modify them to the construction site borders. And this is the example of the acoustic noise barrier. And that's all from me. I'll pass to another group member.
Hi, Assalamualaikum. My name is Muhammad Ridwan. Doctor, can you hear me? Hello?
Yes, can.
Today I want to explain about our discussion. So the first discussion is to discuss the current issue related to environment and see the awareness level among the society. So the first issue is noise can be harmful to construction worker and citizen nearby. And the second is it may cause damage to human hearing system. The noise is produced by construction working. So for example of construction works is piling, welding, knocking, hammering, as well as the transportation process. All of these works for sure will make a lot noise because all of these work are being done using massive machine. Erect the barrier as close as possible to the point of origin. All sites beyond the barrier will profit from this strategy. So the awareness is improve the block, reduce the noise need to be done in the construction site. And the second is reduce the noise need to be done in the construction site. And next slide. So the second discussion is discuss the main factor that influence the efficiency of the system. So the first is the erect barrier as close as possible to the joint of origin. And then second is a barrier acoustic benefit increase regardless of where it is located. So in the most of cases, the barrier mass is not an important consideration. The barrier should be designed so that the penetrate the barrier is lower than the sound that deflect over the top. So the third point is change in the airspeed. The barrier effectiveness can also be affected by change in airspeed, which can cause light wind traveling from the source to the receiver to reflect sound and bend it downward. As a result, the effectiveness of the barrier is lessened. The fourth is sound reflect from the concrete noise barrier. The noise level on the source side of the barrier might rise. Reflected sound will magnify the noise between the parallel barrier, which are placed on the side of the road highway. So the volume at each barrier will rise, allowing the more sound to travel across the barrier and reach the other side. As the result, the barrier are no longer effective as they once were. So the last point is absorption barrier change in airspeed. One absorption barrier may be more effective than one reflective barrier because it is absorb the sound that hits the top of the absorptive barrier. This is because using the sound absorption material to build barrier is more expensive. It is critical to investigate the efficiency of absorption and the best location for it. Next slide.
Okay, thanks for that.
Next slide. So the
Your speaker got some noise. Your speaker, Ridwan.
yeah, doctor.
Ada some noise. Your speaker. You're talking about noise, but actually can from your presentation also you have a certain noise. Okay, that's okay. Proceed.
So the third discussion is discuss the advantage and disadvantage of the system. The advantage is the first is it built with low cost material. It is built in shortened time during the activity of construction, and then it can planted between the road and the barrier. The fourth is vegetation can be planted between the road and the barrier. The disadvantage is they have an impaction or result in the death nearby the vegetation. The second point is the higher of the noise barrier, the greater the noise reducing effect. The third is high noise barrier can be affected by sunlight by casting a larger shadow as the sun rise and sets heat some area. That's all from me.
Okay. So please go to conclusion.
Okay, for the conclusion, noise pollution is a type of pollution that is very harmful to humans, animals, and also ecosystem. The effect of noise pollution to human are as follow. It can cause damage to humans' hearing system, or even worse, can cause permanent hearing loss to human. Very loud noise also may cause disturbance to public living near the construction site. And then the effect of noise pollution to animals and ecosystem are as follow. It may cause disturbance to the animals and also ecosystem. Very loud noise also can cause the animals become rambling and also frightened. So because of that, it may attack the people around them because of the unusual loud sound. So to counter the noise pollution, noise barrier is very practical to be used. It is also very effective and also cost saving. It is also can be installed in the construction site or beside a roadway. For roadway, for metal noise barrier can be used, and for construction site, acoustic barrier can be used. These types of noise barrier can absorb and block loud noise from escaping the construction site. And that is all from us, and I would like to thank everyone for listening to our presentation. Thank you.
Okay, thank you so much, Group 11, for your good presentation, and also your data analysis on the survey and also from the interview. Okay, we go to the question now, because we are still have just limited time. So my question is, noise pollution is an environmental issue or no? From your understanding.
Pada pendapat kami, noise pollution tu memang satu environmental issue lah, sebab bila keadaan sekeliling kita bising kan, so macam nanti dia akan menyebabkan kita sendiri akan merasa macam tak selesa, kita akan rasa tak tenang. So dia amatlah tak elok lah untuk manusia, dan bukan manusia je, juga kepada haiwan-haiwan dan juga kepada makhluk-makhluk lain lah yang tinggal dekat kawasan yang bising tu juga.
So actually it's more on the health problems compared with the environmental problems. Okay, then you said that the noise barrier is the most significant solution for the noise pollution. Betul? So what material is that in the noise barrier?
Contoh macam material yang kita boleh guna, contoh macam kalau construction site tu dia berada dekat tepi jalan, lepas tu seeloknya kalau kita guna material yang absorptif yang boleh menyerap bunyi bising tu. Lepas tu contoh bunyi bahan yang boleh menyerap bunyi bising tu macam foam metal barrier.
Okay, so main causes of noise pollution at the construction, apa dia activity? What activity? Give me example. Other than Syukri, the rest please answer.
Macam kerja piling ataupun kerja-kerja yang dia memerlukan kita guna mesin. So bila kita guna mesin, dia punya mesin tu akan bunyi kuat dan dia akan mengganggu orang sekeliling. Lagi-lagi bila macam aktiviti tu kita buat ramai-ramai, macam buat serentak, so dia akan hasilkan bunyi yang lagi kuat lah dan akan mengganggu orang sekeliling kita.
Alright. Okay. Possible.
Piling.
Okay. Okay, because I believe that most of the students are living together with the housemates. So if your friends make a noise pollution, what you should do? Noise pollution selalu kan, kawan-kawan mau buka je, so nak study tak boleh.
Betul.
Beritahu dengan mereka, kasih mereka tahu dia saya mau belajar ke.
Berkesan ke? So berkesan ke?
Boleh lah rasa.
Yang lain?
Kalau saya kacau mereka time belajar. Kalau dia orang kacau saya.
Macam mana?
Contoh lah, saya tengah belajar, lepas tu dia orang kacau. Bila saya dah tegur, dia tak dengar. Saya kacau balik time dia orang belajar untuk bagi dia orang rasa apa yang saya rasa.
Okay, balas balik Okay, make sense. So if you have a noise measure device ke, you can put in your room ke apa, because you learn that the pollution boleh pergi sampai 85 decibels, right? Kalau lebih maknanya you can make something. Okay, just kidding lah. Maybe it's related lah to your daily life. Okay, that's all for today for group 11. Thank you so much from my class. I think we have more participants can come in to join our webinar. Dr. Shalinda, are you there? Rara, are you in? Rara dah masuk ke?
Ya, saya dah masuk dah.
Apa khabar?
Alhamdulillah.
Puan kita dah masuk speaker. Dr. Shalinda dah masuk dah?
Ada
ni.
Ada tu. Okay, Lin, dipersilakanlah. Akak rekod sekarang. Aku lupa. Lin, minta student masuk lah.
Oh, memang dah minta student masuk lah. Sekejap lagi diorang masuk lah tu. InsyaAllah. Diorang ada kelas tu Kak. Ada few yang ada kelas. Sebab nanti diorang boleh tengok dekat FB kan?
FB tak pandai. Rekod je. Nanti tak bagi Google link.
Okay, boleh.
Recording in progress.
Okay, Lin, pass to you
Okay, thank you Kak. Okay, Assalamualaikum. Dan terima kasih saya ucapkan Assalamualaikum dan selamat petang, dan terima kasih saya ucapkan kepada semua peserta yang hadir pada hari ini yang dapat meluangkan masa untuk kita bersama-sama dengan Industry Talk anjuran daripada MPRC. Alhamdulillah untuk kali ini. Okey, tanpa membuang masa, saya perkenalkan speaker kita pada hari ini. Speaker kita pada hari ini, kita sangat berbesar hatilah kita dapat bersama-sama dengan beliau. Beliau merupakan alumni anda semua dan beliau telah melanjutkan pelajaran degree di UTHM, kemudian diteruskan dengan master di dalam civil engineering juga. Alhamdulillah telah bergraduasi dalam tahun lepas. Alhamdulillah. Betul Rara, tahun lepas ke 2 tahun lepas?
Tahun lepas.
Tahun lepas, Alhamdulillah. So untuk PKP betul, dan combo baru-baru ni Alhamdulillah. Untuk hari ini Rara akan menerangkan berkaitan dengan emission monitoring. Rara sekarang adalah bekerja dengan sebuah syarikat yang mengendalikan emission monitoring, dan di syarikat Tekun IOS Sendirian Berhad yang berkelan di JB. Alhamdulillah. Dan Rara pun telah banyak melakukan kerja-kerja berkaitan air monitoring, dan air monitoring merupakan air pollution merupakan salah satu chapter di dalam engineering yang pelajar, saya percaya pelajar hari ini telah pun habis lecturenya dalam minggu lepas. Alhamdulillah. So untuk lebih memberikan pendedahan dan pemahaman berkaitan the practical work related to air pollution ni, dan apa yang paling close to civil engineer akan buat apa in term of air pollution ni, salah satunya dah air quality monitoring. Dan kita sebagai engineer memang kita dimintalah kadang-kadang dalam BQ arahan kerja JKR diminta untuk kita buat monitoring dan kadang kilang-kilang pun kadang-kadang memang DOE meminta untuk diadakan air monitoring lah. So air monitoring ni antara cabang kerja yang adalah dalam civil engineering. So tanpa membuang masa, saya silakan speaker kita Kak Rara kita. Silakan.
Terima kasih Doktor. Okey, nama saya Nur Syahira binti Muhammad Amdan. Saya bekas pelajar UTHM. Okay, terima kasih pada Dr. Chalinda sebagai SB saya masa saya degree dengan master. Sudi jemput saya untuk berkongsi pengalaman sama adik-adik. Okay, so sekarang ni saya bekerja dalam bahagian environmental, occupational, safety and health. So jadi saya ada memang buat untuk environment, water, lagi untuk safety pun ada kira macam pekerjaan, safety punya pekerja punya keselamatan. Apa kita ada buat juga. Okay, tapi hari ni saya nak kongsikan macam mana kita buat monitoring pada air pollution. Okay, ini sekejap saya buka slide. Okay. So untuk first kali kita kena fahamlah apa itu air pollution. So air pollution can be defined as the presence of toxic chemical or compounds in the air at level that pose a health risk. Then ini apa tu type air pollution gases or particle yang kita selalu measure untuk setiap kilang. Carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen dioxide, total particulate matter (ppm), volatile organic compound. Okey, macam yang ni yang saya tunjuk ni yang selalu usually yang kilang minta kita untuk baca. Tapi ada banyak lagi parameter yang sebenarnya sepatutnya kilang buat, tapi dia depends on dia punya apa yang dia buat lah. Kalau dia buat proses yang ada, kita nanti dekat bahagian ujung kita ada cerita pasal yang ni. Nanti saya just simply kat sini dulu. Then ini impact of air pollution. So daripada apa tu pencemaran alam sekitar ni memang dia akan affect kita punya human health. Macam first kali kita punya pernafasan, then kadang-kadang boleh kena pada kulit kita, ke gata-gata kulit, mata. Ini memang benda ni terjadi pada saya bila saya buat testing tu. sometimes dia macam gases je, tapi bila kita bau, terus kita rasa macam sakit kepala, itu memang efek daripada gases yang tercemar. So sometimes macam bila pergi kilang tu dia punya, mungkin bukan saya kata dia tak ada air pollution system control, tapi air pollution system control dia tak berfunction, then dia memang akan efek dia punya surrounding. So siapa yang datang kilang tu pun memang akan terkesan. So siapa yang bekerja kat situ lagi terkesan lah. So memang air pollution ni akan efek pada human, animals, plant. So macam bila air pollution ni mau pada keluar gas daripada chimney. So chimney tu then hujan akan menyebabkan contamination water pula. So bila contamination water tu akan efek pada kita punya ikan apa semua. So kita pun akan makan benda tu. So benda tu akan efek balik pada kita juga. So pusing-pusing benda ni semua akan efek pada human juga. Human dan alam sekitar. So daripada air pollution ni pun akan menyebabkan plant reproduktif, menyebabkan global warming, greenhouse. So ni semua efek daripada air pollution. So cara untuk kita control air pollution ni, kita boleh amalkan reuse, reduce and recycle. So kita boleh elakkan open burning, pembakaran hutan secara terbuka, pembakaran sampah secara terbuka, dan kita boleh amalkan tree planting. So macam untuk budak-budak sekolah, mungkin kita boleh ajar dia orang cara untuk tanam pokok supaya benda ni pun memang boleh membantu kita punya udara lebih bersih. So yang paling saya nak share, kita boleh elakkan penggunaan produk yang mengandungi VOC. So contoh produk yang mengandungi VOC yang kita selalu guna dalam kehidupan kita, pewangi kereta. So pewangi kereta ni, kalau siapa yang macam kita rasa macam benda tu tak ada apa dekat kita just bau wangi kan. Tapi sebenarnya dia mengandungi VOC yang tinggi. Bila kita buat testing, chemical exposure monitoring, itu memang testing yang kita akan buat pada pekerja yang terdedah kepada chemical tau. Tapi kalau kita buat untuk yang kita ni naik kereta, kita pakai yang produk yang mengandung VOC, so bacaan VOC tu boleh melebihi limit yang dibenarkan. So sebenarnya memang pewangi kereta ni sebenarnya dia ikutkan dia berbahaya. Tapi benda tu kita tak diwar-warkan yang benda tu berbahaya sebab yalah, itu jadi satu macam produk kita kan, kita jual kan. So memang sepatutnya lah kalau boleh untuk pewangi kereta tu kurangkan. Kita boleh gantikan dengan natural punya bahan seperti macam daun pandan, cakol. So kita memang boleh untuk kurangkan bau dalam kereta kan, kita boleh gantikan benda-benda macam tu daripada gunakan yang mengandungi chemical. Untuk jangka masa pendek kita tak rasa apa, tapi bila untuk jangka masa panjang dia mungkin kita akan jadi sesak nafas, macam tu efek dia. So ini antara yang produk yang memang mengandungi VOC lah, grease, macam tu lah, contoh-contoh macam tu lah. So untuk industri pula, apa yang industri perlu buat untuk kurangkan air pollution. So setiap industri ni sepatutnya dia kena ada satu air pollution control device. It depends on dia punya production. Kalau dia kilang kayu, so dia kena cari device yang sesuai untuk dia control dia punya air pollution. Kalau kilang kayu, mostly pakai dust collector. Sebab dia pada kilang kayu dia banyak dust kan. So dia kena cari sistem dust collector. Kalau contoh dia pakai sistem yang tak ada kena dengan dia punya production, benda tu tak boleh capture, so sama je, tak jadi apa juga. So then, so kilang memang kena minta, dia kena hire someone untuk hire consultant lah untuk tahu sistem apa yang bersesuaian dengan dia punya kilang. Sebab setengah kilang dia tak tahu dia buat apa, dia kena pakai apa. So dia boleh hire consultant untuk consultant suggestkan dia, okay dia kena pakai dust collector, dia kena pakai scrubber, dia kena pakai dry spray booth, macam tu lah. So untuk benda-benda ni semua kena submit pada authority, Department of Environmental. So nanti authority akan approve lah sama ada okey ke tak okey ke design kita apa semua. So memang kita akan kilang wajib buat dan benda ni pun dah enforce untuk kena buat. Then okay, bila dah sebut pada authority tadi, authority pula kena ambil tindakan. Kalau ada dia pergi kilang tu tak ada pasang langsung air pollution control device ni. So dia boleh saman atau dia boleh denda, masuk penjara. Memang kena denda yang tinggi. Jangan macam bagi yang murah-murah, sebab sekarang kilang ni kalau kena 10,000 pun dia tak kisah sebab dia boleh bayar. So denda tu bagi tinggi supaya dia orang ada rasa macam takut dan dia orang akan pasang benda-benda air pollution control device ni. So memang kena ambil macam DOE, dia akan selalu ronda kilang-kilang yang mana yang memang target selalu keluarkan gases yang berbahaya. So memang dia akan pergi dan dia buat kerja lah. Tapi banyakkan kilang yang terlepas ni kilang-kilang kecil. Yang kilang-kilang yang kita tak tahu pun dia buat apa. Dia tak tunjuk langsung dia ada chimney ke apa. So DOE pun terlepas pandang pada kilang-kilang macam ni. So then kalau kilang tu dah pasang pula air pollution control device ni, dia kena ada someone pula untuk yang monitor pula device ni. Sebab benda ni dia ada, sometimes dia boleh rosak. So kalau tak ada siapa monitor, benda tu tak rosak dan tak siapa tahu benda tu rosak. So memang kena ada awareness lah dalam setiap kilang industri ke apa-apa ke, yang supaya untuk tengok dia punya sistem tu okey atau tidak. Dia punya air pollution control device tu okey, berkesan atau tak berkesan. Okay, so why air pollution control system required? So macam saya cakap tadi, memang dalam Act, dalam Regulation Environment Quality Act 1974 and 2014 memang menekankan Regulation 7 kena ada air pollution control system. Dengan Regulation 9 pula menekankan performance monitoring of air pollution control system. Means dia kena ada air pollution control system dan kena ada monitoring untuk air pollution control system. So benda ni memang ada dalam regulation. So memang siapa kilang mana yang tak buat, dia boleh kena saman. Dia boleh kena tangkap. Dia memang bersalah. Lepas tu untuk product recovery, needs of production and product quality, compliance to ISO 14001 and good corporate and social responsibility. So ini antara air pollution control system yang sering saya jumpa dekat industri. So mostly scrubber, dust collector, electrostatic precipitator, ini jarang sikit sebab dia pakai elektrik, so dia agak costing. Then carbon filter, carbon filter ni selalu kita akan pasang untuk macam fume hood. Fume hood tu dia just fume, tapi kalau tak ada benda yang boleh filter dia punya fumes tu, so dia terdedah juga kepada udara tu, akan tercemar juga. So memang sepatutnya kalau macam fume hood tu dia kena ada satu filter dekat atas fume hood. Then wet spray booth dengan dry spray booth. So yang ni contoh scrubber. Scrubber ni mau pada macam water treatment, dia nak gases yang keluar tu dia acidic. So dia akan scrubber dia akan treat gases yang keluar tu. So yang ni electrostatic precipitator. Dia sama macam, dia lebih kurang dust collector. Tapi dust collector dia memang capture dust saja. Tapi kalau yang ni dia by ion. Dia pakai elektrik untuk capture the contamination. So nanti yang terlepas tu dia akan jatuh ke bawah. Yang mana berat, yang mana ringan dia akan pergi ke chimney. So yang ni panggil chimney. Then ini carbon filter yang saya cakap selalunya akan install untuk fume hoods ataupun canopy hoods. So kita akan pakai carbon filter. Sebab kalau tak ada filter ni, gas akan terus keluar direct ke chimney. So yang ni wet spray booth dengan dry spray booth. So different between wet spray booth ni, wet spray booth dia ada water curtain. So water curtain ni yang akan capture contamination. So water tu akan pergi ke wastewater treatment pula. Yang gases yang bersih tu akan pergi ke chimney. So untuk yang dry spray booth pun dia tak ada water tapi dia capture by filter. So filter untuk dry spray booth ni dia boleh pakai, depends on spray mist apa yang dia nak capture. Tapi selalunya dia akan pakai yang just filter biasa je. Dia tak perlu nak karbon ke apa semua sebab karbon tu mahal. So dia akan pakai macam PVC filter je. Sebab dia cuma nak tangkap capture spray mist. Okay. So untuk satu sistem air pollution control system, dia complete dia kena ada hood. Lepas tu dia kena ada ducting. Dan dia kena ada air pollution control system. So dia kena ada fan and motor. And lastly chimney. Tapi mostly kilang kebanyakan dia tak ada air pollution control system. So bila dia tak ada air pollution control system, kita akan panggil dia sebagai local exhaust ventilation system saja. Kita tak boleh panggil dia air pollution control system sebab dia tak ada. Tapi yang paling penting dia kena ada fan dengan motor. Sebab fan dengan motor ni lah yang sedut dia punya contamination dan lepaskan dia punya contamination. So kalau satu sistem tu tak ada fan and motor, dia memang tak boleh, dia tak dipanggil sebagai LEV system ataupun air pollution control system. Tapi kalau kita jumpa contoh satu sistem tu tak ada hood, dia still panggil air pollution control system selagi dia ada air pollution control system. Tapi kalau dia tak ada air pollution control system, dia panggil local exhaust ventilation system. Okay. So kebanyakan kilang dia memang tak ada chimney lah. Memang kita takkan sorok chimney sebab dia tak nak authority datang, kilang dia tengok apa semua. So dia potong chimney, so tak tahu pun dia ada device ni dalam kilang dia. Macam tu. So the performance monitoring requirements, dia punya requirements ni untuk kita tingkatkan kesedaran industri tu untuk lebih bertanggungjawab dia menjaga alam sekitar daripada dia asyik macam buat membuang dia punya bahan-bahan tersisa tu. So kita buat performance monitoring tu supaya dia lebih jagalah dia punya sistem tu. Then to ensure the air pollution control system operate dengan baik. Lepas tu dia kena carry out periodic and continuous monitoring untuk dia punya air pollution control system. So kalau untuk periodic tu dia kena buat hari-hari, continuous selalunya setahun sekali. So yang ni memang kalau yang untuk monitoring requirements ni kita minta dia supaya dia compliance with the limit value. Then the frequency of monitoring will depends on the type of industry of air pollution. So dia saya cakap dia ada periodic measurements dengan continuous measurement. Periodic measurement mostly orang yang buat tu orang yang bekerja dekat kilang tersebut. Memang dia akan hire dia punya manpower. Tapi kalau continuous measurement dia kena ambil consultant untuk buat dia testing dekat dia punya kilang. Lepas tu dia akan compare lah dia punya periodic dengan continuous. Kalau contoh periodic dia dapat okey, continuous dia dapat tak okey. Mean ada something wrong. Mungkin orang yang buat hari-hari tu tak buat pun. Cuma just tulis dia okey. So yang tu yang pentingnya continuous. Sebab benda ni bukan orang dalam buat, orang luar buat, third party buat. Bila third party buat, third party akan keluarkan result yang exactly, yang betul. Okay, so monitoring apa yang selalu kita akan buat untuk air pollution control system? First, local exhaust ventilation system testing, LEV, air emission monitoring, stack sampling, ambient air monitoring, indoor air quality, chemical exposure monitoring. Okay, ni monitoring ni semua memang dia macam ada relationship. Contoh kalau satu sistem air pollution control system, dia memang kita akan panggil testing dia sebagai LEV testing. Kita tak panggil air pollution control system testing, kita panggil LEV testing. Okay, lepas tu untuk yang dia punya gases yang keluar tu panggil air emission monitoring. So untuk ambient air pula kita akan buat surrounding punya dekat factory. So kalau contoh dia punya kita terus dia memang ada kena mengena. Kalau air emission dia okey, means ambient air monitoring dia pun akan okey sebab air emission dia keluar daripada chimney. So ambient air monitoring udara di sekeliling kilang. Benda tu memang ada relationship. So indoor air quality pula depends on dia punya LEV system. LEV system dia okey, indoor air quality dia pun akan okey. Chemical exposure monitoring pun sama juga. Dia akan depends on LEV system dia. LEV system dia function well. So dia punya chemical exposure monitoring pun akan okey. Result akan okey. So semua ni memang akan ada kena mengena. Dan hari ni saya akan tekankan cara kita conduct air emission monitoring, which is stack sampling. So air emission ni sebagai physical flow of gases or particle matter that economic system production or consumption process to the atmosphere, means gases yang dilepaskan melalui chimney ataupun exhaust. So memang dilepaskan kepada surrounding atmosfera. So dia punya air emission monitoring ni satu testing yang kita conduct on site And then kita akan dapat result on the spot. Kita dapat result on the spot, tapi memang akan dapat result time untuk masa kita conduct tu. So after that, result yang kita dapat tu kita akan hantar ke lab. Kalau kita ada lab sendiri, kita boleh buat sendiri. Tapi sometimes dia punya result tu macam, yelah hilang kalau dia tak lepas, dia boleh bayar orang. Tapi kalau kita hantar third party, dia tak boleh bayar. So memang akan dapat result yang exactly apa yang dikeluarkan oleh kilang tersebut. So apa benda yang equipment yang kita guna untuk conduct air emission monitoring ni, macam first rocker height flow pump, medium flow sampler, flexible connecting tube, absorbing solution, filter paper dengan integer bottle. So ini antara alat-alat yang selalu saya gunakan. Okay, yang ini medium flow sampler ataupun high flow pump. Okay, yang dua pump ni berbeza flow rate. Jadi kena tengok parameter apa yang kita nak capture. Kalau parameter tu pada macam total particulate matter, so kita akan pakai yang high flow pump sebab dia berat. So kena pakai flow pump yang tinggi lah. Tapi kalau kita nak capture gas macam VOC apa semua, kita akan pakai medium flow sampler saja. Dan yang ni termometer untuk cek suhu dekat chimney. So ini CO meter. CO meter ni depends on sistem apa. Kalau macam gases biasa tak ada CO, tak ada carbon monoxide. Tapi kalau untuk burning ke macam oven ataupun generator set, yes, dia memang akan hasilkan CO, carbon monoxide. Okay, ini integer. Integer ni untuk kita letak solvent, which is absorbing solution. Kita akan letak dalam integer ni. So integer ni akan connect dengan flexible tube. So daripada pump ni akan tarik udara yang tercemar tu masuk dalam integer ni. So daripada integer ni solution yang kita dapat tu kita akan bawa ke lab. So kalau untuk PVC filter ni kita akan pakai untuk capture TPM, total particulate matter. Untuk untuk charcoal tube ni kita mau pada capture volatile organic compound. So ni alat-alat yang selalulah saya pakai untuk air emission monitoring. So jadi yang ni method cara kita conduct air emission monitoring. So macam untuk gambar yang pertama ni, ini sebenarnya kompresor. Tapi kompresor sepatutnya dia tak ada keluarkan apa-apa gases pun. Tapi setengah kilang dia concern, dia punya pekerja lalu dulang alik dekat dia punya kompresor. So dia nak buat apa gas yang keluar daripada kompresor. So masa untuk testing ni kita akan buat testing CO. Selalu saya buat SO2, sulfur dioxide gases, nitrogen dioxide gases dengan total particulate matter. So kita akan check 3 jenis tu dulu dekat kompresor ni. So ini cara kita conduct, memang kita akan letak hook tu dekat mana gases tu keluar. Then sambungkan gases hook dengan flexible tube tu dekat solvent dengan pump. So daripada situ tunggu, kalau untuk TPM masa dia 30 minit. So kalau untuk SO2 pun 30 minit. Dia different parameter, different cara nak buat dia. So kalau macam SO2, NO2, SO2 30 minit. Kalau untuk non-volatile organic compound 1 jam. So kena tunggu 1 jam untuk buat benda ni. So kalau macam yang ni kompresor, ini chimney. Ini chimney biasalah. Memang chimney ni okey. Untuk chimney pun tengok dia duduk atas bumbung dan dia akan 3 meter tinggi daripada aras bumbung. So daripada situ sampling point dia akan duduk dekat sini. Area-area ni je. So macam yang ni sampling point dia. So kita akan masukkan hook dalam sampling point. Lepas tu kita akan set up lah dia punya pump apa semua tu untuk sedut gases yang keluar daripada chimney tersebut. So macam ni kita akan tengok dia ada set numbering apa semua. So ini sebagai reference kita lah. Kita buat chimney nombor berapa sebab bukan satu kilang satu chimney. Kebanyakan kilang ni dia ada sampai 10 chimney. So yang ni reference kita lah. Kita kena tahu chimney nombor berapa kita buat. Dan chimney ni pergi ke mana pula? Sistem apa yang dia pergi? Dust collector ke? Scrubber ke? So kena alert benda tu. Kita kena tahu walaupun kedudukan chimney ni atas bumbung. Tapi kita kena tahu bawah bumbung ada apa. Okay. Lepas tu yang ni pula untuk genset. Macam genset ni dia tak ada official chimney. Dia pakai exhaust. Macam ni pun kita boleh buat apa tu, air emission monitoring. So hook tu kita akan letak dekat exhaust dia. So macam saya cakap, genset dia something dia burning, so dia akan menghasilkan karbon monoksida. So sini kita akan ambil bacaan karbon monoksida melalui CO meter. So daripada bacaan ni kita sebabkan karbon monoksida ni dia bukan bacaan dia akan fix terus dapat contoh 100. Tak. Dia akan ikut dia punya perubahan. Kalau kita jauh daripada tempat ni, dia akan kuranglah bacaan CO dia. So kita akan kena ambil gambar time kita buat betul-betul dia keluar tu. Berapa nak tahu bacaan CO dia. Kalau macam kita duduk dekat open air, CO tu takkan ada. So memang cara nak proof yang dia memang menghasilkan CO macam ni. Memang kita akan capture gambar lah untuk tunjukkan yang dia ada keluarkan CO. So dia ni sini ada bacaan CO dengan bacaan temperature. So ni dua ni kena ambil. Kita kena alert lah untuk benda ni. So yang ini method yang kita gunakan untuk calculate concentration setiap gases tu. Okay, macam CPM kita akan pakai US EPA 3002. Kalau macam sulfur dioxide kita pakai US EPA method 8. Nitrogen dioxide US EPA method 7. And chlorine US EPA method 26A. Hydrogen chloride US EPA method 26A. Hydrogen sulfide US EPA method 11. Ammonia US EPA method CPM 027. And carbon monoxide kita guna carbon monoxide detector. Then for dark smoke kita pakai Ringelmann check. Okay, macam method US EPA ni kita boleh refer. Okay, macam ni contoh method dia. Yang ni method US EPA method 8 untuk dapatkan bacaan sulfur dioxide emission from quaternary source. So daripada sinilah method ni kita follow lah. Apa yang dia kena buat semua. So macam ni lah kita refer method-method ni untuk buat setiap testing tu. So dia macam sama juga, dia ada condition dia. Kalau kita akan pakai based on condition keadaan dekat site macam mana. So kita boleh sambil tu boleh inilah kalau boleh baca lah dia punya method ni. Okay, lepas tu okay, after yang kita dah dapat sampel, macam saya cakap kita akan hantar ke third lab untuk buat analisis. So lab tu akan keluarkan result dalam bentuk gram dan ataupun miligram. So macam ni contoh result yang saya tunjuk ni untuk testing direct from laser machine dengan after from portable fume machine. So macam daripada sini, daripada result ni saya nak cerita sikit macam okay, macam direct from laser machine ni dia laser machine yang untuk buat baju. So bila dia laser tu dalam satu mesin, dia akan keluarkan gases yang sangat banyak sebab dia macam satu pembakaran lah, sebab laser kan panas kan. So dia kena dekat satu macam kain ke apa, dia macam terbakar. So jadi dia punya result dia 0.0236 gram. Tapi kalau untuk yang after from portable fume machine ni, result yang after dia dah tarik suction daripada portable fume machine. So result dia rendah. Sebab dia dah macam yang ni direct, yang ni yang dah after filter. So tengok bila after filter je, dia punya result tu akan dapat sikit. Memang maksudnya memang function lah macam portable fume tu betul-betul membantu untuk mengurangkan pencemar udara yang keluar tu kotor. So memang sepatutnya apa-apa sistem yang menyebabkan gases tu memang sepatutnya kena pakai satu alat yang boleh sedut udara yang kotor tu. Okay, so daripada yang result ni memang kita tengok result yang tak ada portable fume ni semua tinggi. Tapi yang after portable fume ni semua rendah. So sini dah proofkan yang memang kita kena pakai alat yang untuk sedut udara. Okay, so yang ni result untuk result yang tepi ni, ini cara calculation dia. Yang untuk lab akan untuk dalam gram dengan miligram. Tapi kita nak tunjuk dekat klien ataupun industri dalam bentuk concentration. So dia punya unit dalam miligram per meter cube. So yang ini, so cara dia memang kena ada ambil temperature Then kalau masa ni untuk reference kita lah. Okay, macam yang ni untuk TPM and nitrogen dioxide, sulfur dioxide, kita akan pakai flow rate 16. Tapi kalau untuk NMBOC, kita akan pakai flow rate 0.2. So ini formula dia yang kita akan buat, kita akan masukkan dia punya flow rate, then darab dengan dia punya masa testing. Lepas tu kita akan bagi dengan 100, lepas tu darab dengan temperature untuk dapatkan dalam meter cube. So daripada meter cube ni kita nak meter dalam milligram per meter cube. So result yang daripada ni bahagi dengan meter cube ni akan dapat concentration. So daripada sini kita nampak concentration dia 56.461 untuk TPM. Untuk nitrogen dioxide 2.823, untuk sulfur dioxide 11.484 mg per meter cube. Okay, so daripada result ni kita kena compare pula dengan yang dalam Air Quality Act 2014. So yang ni table ni kita boleh refer untuk different industry. Okay, macam contoh industri tadi tu yang untuk result yang ni kita refer pada chemical, electrical and petrochemical industry. Sebab dia memang tak ada, dia pakai dia buat baju. So memang dia mau pada chemical sebab memang cara buat baju tu pun pakai kan benda-benda chemical kan. So kita refer pada chemical. So tadi tu result untuk TPM 50 mg per meter cube. Kalau result tadi dapat 56.461 melebihi 50 mg per meter cube. Means dia dah melebihi limit value. So maksudnya kalau benda tu tak diuruskan dengan baik, macam laser machine tu tak ada apa-apa yang kita buat untuk protect dia punya untuk cover dia punya gases yang keluar. So memang dia akan menyebabkan contamination dekat area tu. TPM dia tinggi. Itu baru buat 1.5 jam. Kalau mesin tu jalan sampai dalam masa separuh hari, berapa banyak contamination dekat area tu. So yang daripada sini yang kita kena alert lah. Okay, macam yang TPM nampak. So 50 mg per meter cube. Tapi macam untuk SO2, NO2, okay lah result dia bawah daripada 700 meter cube per meter, mg per meter cube untuk NO2 dengan 200 untuk SO2. Sorry, untuk SO2 100 mg per meter cube. So yang ni kita boleh refer as tadilah untuk chemical, electrical and petrochemical industry. Kalau untuk industri lain, kita refer industri lain lah. Okay, so macam saya cakap tadi, dia setiap industri ada parameter yang dia nak kena measure. Tapi macam contoh macam boiler, dia punya parameter SO2, NO2, SCI, HF, carbon monoxide, total particulate matter, Hg, mercury. Okay, so memang banyak parameter dia. Sometimes benda ni semua macam kilang tak nak buat. Tapi so lah saya cakap macam enforcement daripada authority, sepatutnya authority kena tahu benda-benda ni so dia boleh check sama ada betul tak kilang ni follow apa yang regulation yang keluar ni. Memang ini regulation daripada Environment Quality Clean Air Regulation 2014. So kalau kilang tu tak buat, sepatutnya dia boleh saman ataupun boleh buat something lah kat kilang yang tak nak buat benda-benda testing ni. Okay. So dah after tu kita akan tengok pada dark smoke. Okay, macam dark smoke ni kebanyakan chimney dia memang keluarkan gases yang macam tak berapa gelap. Tapi dia still ada juga nampak juga keluar macam kelabu-kelabu asap kan. So kita kena buat testing juga. So daripada Ringelmann chart ni kita ada 5 chart yang menunjukkan dia punya opacity, dia punya macam kepekatan asap tersebut. Okay, so kalau untuk Ringelmann chart nombor 1 memang betul-betul clear. Ringelmann chart nombor Ringelmann chart nombor 0 clear. Ringelmann chart nombor 1 macam kelabu sikit. Ringelmann chart nombor 2 kelabu lebih sikit. Dan yang terakhir sekali yang Ringelmann chart nombor 5 akan terus hitam legam, memang gelap. So untuk buat testing ni dia cuma dia tak ada pakai device apa-apa, cuma dia akan pakai yang itulah table Ringelmann chart ni kita akan letakkan dekat dengan, bukan dekat, dalam around 15 meter daripada source gases tu, daripada chimney. So kita pula nak kena duduk supaya sampai nampak table ni nampak macam jadi warna. Jadi macam gelap, putih, kelabu asap, kelabu macam tu. Dia tak ada spesifik berapa meter kita nak duduk. Tapi sampai kita nampak table yang kita tengok ni nampak gelap sikit, nampak gelap cair sikit. Kita macam tu tau. So memang nak buat dia